Welcome everyone to our lecture on projectile motion. So this lecture is in the continuation of the series of kinematics, and today we'll try to study how when a ball thrown on a flat surface at a particular angle with the surface, how it moves and at what time will it return to the surface from which it is projected. And basically how, and not only how, we are going to study the motion of particle in two dimensions. Projectile motion is a very nice topic which helps us understanding that. So let us take a few real life examples first. Let us take an example where you have two friends and they are passing ball between each other. So if there is a friend at this position and there is one friend at this position, so the motion of the ball would be somewhere like this, and the path followed by the ball would be somewhere like this. So somewhere down the line, at an intuitive level, we know that how the ball would be moving, but here we want to know at what velocity the ball is thrown. That sometimes when the ball is thrown at a slower speed or at a faster speed, then how will the ball behave, whether the ball would land behind you or whether the ball would land in front of you. So such cases. One more popular case which we encounter in daily life is that when there is a batsman and batsman hits a ball to a 4 or a 6, then at what angle should he aim to hit the ball to, so that the ball reaches maximum height or it has maximum chances of crossing the boundary. So all those things would be covered in this particular topic. So let us start. So first let us draw a simple graph. So this is our x-axis and this is our y-axis. Let us say the ball is projected with some velocity v. This is the ball and it's projected with some v velocity at an angle theta. So it follows some path and it comes back to the horizontal which it is thrown from. So mainly there are three things which are mainly asked in questions. The first thing is t, which is called the time of flight. As you can guess from the name of this variable, this is the time taken by the particle to complete its whole journey. Next, what is asked is capital H, or sometimes it as H max. It is the maximum height reached by the particle above ground. Height reached. And the last which we would focus on is the range of the body. The range of the particle is simply the horizontal distance covered by the particle before it strikes the horizontal. Okay, so before proceeding further, we will be taking some important assumptions in our derivations. We'll be taking some assumptions. Assumptions are very important to idealize our real life cases. So the first assumption which we are going to take is that the acceleration of gravity, which is g, that is going to be a constant. Actually, when we go above Earth and below Earth, then above Earth at some particular height, then the acceleration of gravity changes with height. So first we would assuming that acceleration due to gravity is constant, so that we can use the equations which we used in motion under gravity, or somewhat we can relate to it, because we are studying motion with uniform acceleration. So it is important that we are able to utilize the equations which we have learned, that is v square is equal to u square plus 2s, v equal to u plus at, and so on. Second, we would assume that the surface on which we are throwing is a flat surface. That we would be assuming that Earth is flat. Third assumption which we would be taking is that there would be no air resistance when we would be throwing the ball. No air resistance means that the forces of air particles on the ball moving through it would be negligible, or there would be no force. So that we can say that the only force acting on the particle is the force of gravity, and the action to gravity remains a constant. So let us begin. So these are our aims, primary aims: the time of flight, the maximum height reach, and the range of the particle. And the variable which we are starting with is the velocity, because what we have in our control is the velocity v at which we are going to project the ball, that is v. Velocity of projection. Projection means simply throwing the ball. So this implies that at what initial velocity the ball starts. Theta is called the angle of projection. And then we are supposed to proceed further. So first we will talk about acceleration. We know that the acceleration due to gravity is downwards, and the downward direction is a negative one because the upward direction is positive. So we take the negative sign in front of g and say that action gravity is negative. To make it a vector, we can say j cap, and this becomes a vector. And this is the acceleration of the ball. Okay. So now what we are supposed to learn here, these are the variables, and they're just some names which are important to us, that is what is time of flight, what is maximum height, what is range. What we are supposed to learn, or what we are supposed to gain from this situation. So whenever we are doing problems of particle being thrown like this in air, we take a common approach, and there are some common ideas which we keep in our mind. So one of those common first ideas which we take in our mind is, what is the initial velocity? So you would say that, okay, the velocity with which you are starting the motion is v, and that is given to us. So what is to investigate there? So when we are talking about motion in two dimensions, then we have to study the motion by dividing it in x and y axis. So we would be writing separate equations for x axis and y axis. Now the acceleration is only along y axis, so that's okay. But when it comes to velocity, we would be writing in terms of x axis. So first what we do is that we try to, or what we are supposed to keep in mind is that we try to find the velocity or the initial velocity of the body as it is thrown along the horizontal. By that we mean is, what is the velocity of the particle along the x-axis. So the velocity of the particle along x-axis can be taken by simply taking a projection of our velocity. So this velocity is v cos theta, because we know that the component of a vector with the theta is v cos theta, and the component of this velocity vector perpendicular or along y-axis is v sin theta. And this is how we actually write the velocity, initial velocity of the body, v cos theta I cap plus v sin theta j cap. So this is the initial velocity. So that should be very simple for us to understand that when we are writing the velocity of the body, then we are comfortable with it. that if we are knowing the velocity of the body as it is projected and the angle of the body as it projected, then we are comfortable writing what is the v cos theta, what is v sin theta, whether we are comfortable writing the velocity vector, and we understand what is happening. So the initial velocity of the body along x direction, what would that be? So we can go over here. So the initial velocity of the body along x direction, ux, initial velocity in x direction. So this, as you can see, this is v cos theta. So the initial velocity along x direction is v cos theta, and this should be the coefficient of I cap, velocity along x axis. So what was this velocity from? This velocity was from v, and we took its projection along x axis, and it has a very clear consequence. Now if I were to ask you what is the acceleration of the ball along x axis, you would say 0. There is no acceleration along x axis. So should the velocity along x axis change if there is no acceleration? The answer is no, it should not change. So that means that the initial velocity would remain constant throughout the motion. It would remain v cos theta. Okay, now let us think about the initial velocity along y-axis. So initial velocity along y-axis is v sin theta, and this is simply the perpendicular of this right angle triangle. This is the velocity, and the perpendicular of the right angle triangle is the sin theta of the hypotenuse, and this initial velocity hypotenuse is v. So that's why the velocity along y direction is v sin theta. So this is the second thing which we have learned, that okay, we take the initial velocities, and the second thing which we are talking about is that now we think in the axis in which acceleration is present or not. The first thing which I told you is to look for the horizontal components of velocity. To resolve the to look for horizontal components of velocity and vertical components of velocity. Second thing to look for is along which component is acceleration present and along which component the acceleration is not present. So the acceleration is not present along x-axis. That means there has to be no acceleration along x-axis. The acceleration is present along y-axis. That means there has to be some acceleration along y-axis. So this is what we have to keep in our mind. So let us try to write the equations from which some things would be coming out. So let us write the equation of displacement along x. That would be x is equal to uxt plus half axt square. So as you can see, we are quite used to writing the equation, right? X is equal to u2 plus half axt square. So when we are studying the motion of body in 2 dimensions, we can simply put x under the symbol of initial velocity and acceleration. We can put simply x over here under initial velocity, and we can put an x under acceleration. So when we are putting an x under initial velocity, then it would look something like this, and it would represent the initial velocity along x direction. Similarly, when we are putting an x under acceleration, then it would represent an acceleration along x direction. I would just like to emphasize on this point that the equations which we have studied in straight line, we can simply convert them in the equation of motion in 2 dimensions by putting x under the initial velocity and acceleration. If we are talking about x, let's say we want to write the equation of y coordinate of the body, we would say that u by t plus half ay t square. So I hope that is pretty clear. it was pretty easy to write the equations. We are simply putting the y below initial velocity and below acceleration to get the equation of y. So now the acceleration along x-axis is 0 because the body has no acceleration along x-axis, it's only along y-axis. So this terms cancel out immediately, and we can write the result that the initial velocity or the position of the particle x at any t time is simply v cos theta into t. And if I had to write what is the y coordinate of the particle, then that would become v sin theta into t minus half gt square. So again I would like to emphasize what is we are supposed to put here. We are supposed to put initial velocity along y-axis, so that we have already calculated v sin theta, so that is what we substituted here. And what is the acceleration along y-axis? It is minus g, so that is what we substituted over here. The rest all remain same. So these are the key equations which we are looking for. Okay, so we will proceed further. Yeah, so we'll proceed further. So further we would say that okay, we were arriving at the equations x is equal to v cos theta into t, right? So that means that if we substitute the value of t, we would get the position of the particle at any time. So this is a very important thing, that irrespective what is the motion happening in y direction, we can substitute the value of time and we can get the position of the body at any t time. Similarly, we can write the equation of body in y direction, that is v sin theta into t minus half dt square. So again we can say that if we are to substitute any value of time in this equation, we can get the y coordinate of the body, and x comma y, they completely represent the position of the body at any t time. So what can we gain from these equations? So first of all, let us try to find at what time would the body reach the highest point, just for the sake of our curiosity and proceeding this equations further. At what time would the body reach its highest point? That is, it would reach h max. So we don't want to find h max immediately, we want to find the time. And can we say that the time taken by the body in starting from the initial point and coming to the highest point, that is the time taken by the body to start from origin to reach the highest point, would be same as the time taken by the body to go from highest point to the lowest point. Shouldn't these times be same? Now by symmetry we would be able to say that these two times must be same, and since these two times must be same, if we combine these two times, we would simply get the time of flight, and we can easily calculate the time at which the body is at highest point. How do we do that? So we can easily find that by writing the equation of velocity. Let us write the equation of velocity in y direction. The equation of velocity in x direction is simply v cos theta, it is not changing. In y direction, the velocity would be initial velocity in y direction plus acceleration in y direction into t. Initial velocity in y direction is v sine theta, acceleration is g into t. So at the highest point, we would say that the body is not moving any more further. This is same as saying that when we were studying motion under gravity and we were projecting a ball vertically upwards, then the ball simply reached at the highest point and for a moment its velocity was zero. So in the same case, in the same way, we can say that even if the body is moving in two dimensions, its vertical motion follows the same kind of equations, same idea as in motion under gravity. So the velocity in y direction must be zero at highest point, because if it is not zero, then it would travel either up or down. So in both the cases it won't be at the highest point. So at the highest point its velocity must be zero. So we'd say that its velocity can be momentarily be assumed to be zero at highest point. So this gives us time t is equal to v sine theta by g. If we put this equal to 0, we would get time this. That means the total time taken by the body to complete its whole motion would be simply 2 times the time taken by the body in coming to the highest point. So this is the time of flight. Next, let us study the maximum height reached by the body, h max. So can we use this particular time, that is the time taken by the body to reach the highest point, and put it in y? So the answer would be yes. If we put the value of time into y coordinate, then this particular height is nothing but the y coordinate of the body. So we would say v sine theta. We are substituting in this equation the value of time. The LHS is h max. So v sine theta into time, that is v sine theta by g minus g by 2 into t square. So we square the value of t, we get v square sine square theta by g square. Cancelling 1g, we would get v square sine square theta by g minus v square sine square theta by 2g. So this is h max, and h max would simply come out to be v square sine square theta divided by 2g. So this is the maximum height at which the ball can reach above ground. Next, we want to find what is the range of the motion of the body. So to find range, we will simply take x. If you can just go back to the figure which we are looking for. In this figure, we can say that this particular distance, that is the distance traveled by the body along x-axis. This is x which we are looking for. So when the body has completed the whole motion, the body would come somewhere here, and this distance from the start of the motion to the end of the motion, that is what we have defined as the range of the motion. That means this complete distance would be the range of the body, and since this is the range of the body, we can calculate it. Range. So how do we calculate range? We can use the equation of x. X is v cos theta into time, and time is given to us as, the total time of motion is given as 2v sin theta by g. So we know that 2 sin theta cos theta equal to sin 2 theta. So this comes out to be v square sin 2 theta divided by g, and this is range. So this is the range of the projectile. That is how far the body would reach before hitting back to the ground. So if I can just draw it, this is called the range. This is range, and the total time taken is t. Okay. So one of the initial result which we can remember is, what is the maximum range of of the particle? What is the maximum range of the particle? The maximum range would be when this equation is maximum. When this value is some maximum value. So how to maximize this? So when we are talking about maximizing range, we are not saying that okay, just throw the ball more quickly. We are not trying to increase the velocity. That's not what we are trying to do. We are trying to change the angle of the body at which it is thrown. So when is sin to theta its maximum value? The sine angle or sine trigonometric ratio can only take a maximum value of 1. That means that the angle at which it would be maximum 2 theta would be 90 degree, because sine of something is 1 when the angle in it is 90 degree. So 2 theta is 90, and that means theta is the angle 45 degree. So this gives us a good idea. When a body is thrown at an angle of 45 degree, then the particle reaches the maximum range which it could reach for a given velocity. So thanks for joining this particular lecture. In the next lecture, we will be continuing with the questions on the topic of projectile, and there are plenty of questions. So we will be continuing with that in the next one. Thank you.